Lesson 12 is the start of the data science introduction to the course. We will start, actually we'll use the Vanderplas book for this book, or for this block. Vanderplas is the one that says Python Data Science Handbook. So because I didn't think that Langtongen did a great job of explaining matplotlib and NumPy, I went out and found us a better book that did that, and I think the Vanderplas fits sort of what we want to do. We will start by learning the numerical Python package, so NumPy as it's generally called, and then we'll learn, or we'll talk about dictionaries, which is a base Python data structure that's a little bit more advanced than lists and tuples. We'll talk more about strings. We'll learn about the regular expressions library, which is a very powerful library if you're going to be to do data scraping in the future, or you're going to do something with strings. So we'll talk about that then. We'll then move to data frames, which is a pretty important idea and concept. I know R sort of comes with data frames as one of its regular data structures, but in Python we import the pandas package in order to use data frames. And then the other part is the matplotlib library that sort of replicates MATLAB's data visualization package. It's a very fast-paced block with a lot of more libraries to learn than we did in the first block, so keep up and enjoy. Numerical Python is all about the NP array data structure. Make sure that you read the Jupyter Notebook, which should also I understand these Jupyter Notebooks are rather long in on these 3 lessons, but what I wanted to do is provide you with a resource, and the author, the Vanderplas book Vanderplas, the author of the book that we're using, gave us a pretty good reference Jupyter Notebooks in order for us to reference. So I wanted to compile those all together and hand them to you guys in order to be able to reference whenever you need them. But what I really would like you to do is really understand the power and the difference between lists. And gets overlooked by some students, but just make sure you figure out that you can't add 2 lists together. When you put the plus operator on 2 lists, it just appends the one list to the other, or it combines the 2. In numerical Python, you do that. You get these 2, if you want to call them lists, or arrays, if you will. When you put the plus operator with them, it tries to add them together. So it's trying to do some kind of numerical computation on them, and we'll see that today. There's this thing called broadcasting that we'll get into probably next class. But lists are very, very flexible. Numerical NP arrays are not flexible, but they're more powerful in the computation world. That's sort of the idea, right? So that's the difference between the 2. All right, so you can kind of see some of the things that we're going to do. We're going to import NumPy. I'm going to show you the standard way we're going to do it in the class. You're going to create NumPy arrays in various different ways, and we'll do some computation. We'll concat them together. We'll show you how to do that very quickly, and we'll do some matrix multiplication. We'll be done with this video. And then 2 and 3, I think I'm going to do broadcasting in video 2 and maybe some row reduction stuff. Broadcasting / the mathematics behind row reduction, and then in video 3 we're going to actually we'll actually program up the row reduction piece based on the last. So I'm not sure how long it's going to take, so the math may move into video 3. But the programming part, once you get the math done, is relatively simple. All right, here we go. So, and what I did was I just kept gave you some, so you don't have to sit here and see me typing in all these numbers here. What you can do, the first part is the import of NumPy. So in general, on most programmers, Python programmers use NP as NumPy's sort of 2 letters to reference it by. If you remember before, we used import math as M. Here you're going to import NumPy as NP. So if you do that, now you do NP dot, you can see all of the different things that you can do. Just like math, when you did M dot, once you've done this import here, you can see all the things that you can do. So we've imported it. The first thing that we're going to do is we're going to create some NumPy arrays. These are using lists. So you can take a list, and as long as they have the same, in this case they're integers, but NumPy will convert them to floats unless you tell it you want it to be an integer. And I don't think we're going to get in that today. I think it's in the Jupyter Notebook, but But you can actually tell it that I want this to be an integer if you want it to. In other words, it's going to be maybe some index later on, and we will actually do that later on in the class. But you can just use a list. And the way you do it is V is NP array. So press F9 and come over to the variable, the folder here, and you can see the type, right? So it's a little different than what it was before. It's not all. So you can see the index is here. The index for this one is 0. The index for this one is 0, 0, and you can kind of see what's going on here. Now this is size 3 and a comma. That's 3 elements, and there's really no other dimension to it. So that's what this means. There's only one. This is a one-dimensional vector, and we're going to reshape it here in a second. Maybe if you have never used linspace before, I know we've programmed that one already, but this is the reason why I wanted you guys to program linspace, is so that you can see that you can actually use it in numerical Python as well. It's a MATLAB function that numerical Python has sort of copied, and then you can do W and you can look at it, and again 20, 35, 20. So they look the same. So these two they both have the 3 in the comma, 3 in the comma. So there's 3 elements in this numerical Python array. And here's another one. So this is just 2 different ways of doing it. So you can see that we can also make a 2-dimensional array. So if we can find A here, we open it up. So now you have sort of a matrix, if you will. And this is the way that we will do matrices in the future. We'll use them. We'll make them numpy arrays. So you can see int 32 is the type, right? Because these are all actually these are all integers. Okay, so this is a little different than what I thought it was going to happen. So I thought these were all going to be floats. You can see that W is a float 64. So each element in here is a float 64. Each element in here is an integer. -5, 10. Yeah. So as long as they're the same, numerical Python will make them the same unless you tell it. I mean, there's a way to have a structured data, a structured way of telling that each one of these are going to be different. But again, those are sort of like very nuanced things in the language. All right, let's figure out a couple of different ways. So you've seen taking a list and passing it in as an NP array. You've seen nested list as an NP array, which becomes our matrix sort of representation. And then now let's use another one that you're gonna need. So let's call this one Z, and we're gonna let that be np.zeros. Zeros is a very important one. And the only thing, so MATLAB also has a zeros function, but what MATLAB does is you just got to put the numbers in here. The only difference is you either make this the only difference in Python is you either make this a list or a tuple. So I'm just generally going to just make it a tuple. And let's see, I wanted a 3 by 5 zeros matrix, and if you hit F9, you can also just hit Z and it'll print it off here. You can see that this is a 3 row by 5 column, right? So 3 rows, just like linear algebra, 3 rows by 5 column matrix. Let's see, what's another one? How about the identities are pretty important, so I'll let that be I, and then np.eye. And in general, you're going to just have one number here. So most of the time when you're dealing with the identity matrix, it's going to be just a number here. And then we can print out I, and you can see it's the 4 by 4 identity matrix. There is a way to make it not square, but we're not going to worry about those right now. This is an introduction. Let's let R1 be something. So let's go np.random. So random. I know that's weird, but random is a package in numerical Python that allows you to bring in random variates from different distributions. And the random distribution, I would have rather them called this the uniform distribution, but they didn't. In general, when you're talking about a random number, just like we talked about earlier in this course, it's a pseudo-random number, and what they do is they just take the m, and I don't know if you guys remember, but there's this m that you're trying to get full period of, and you divide every number by m, and that will make all of these sort of hopefully look like a uniform 0, 1 number. So that's why they do it. So it's the random uniform 0, 1, and so I don't know, let's make it 5, 1. Oh, you got to put a tuple. Remember, you got to make it a tuple, and then hit F9, and then R1, and we see that these are, man, those are pretty close. Let's do it again. F9, F9. All right, so good. Man, for some reason in these 10 numbers here, there was 3.91s, which is, I don't know, it's again pseudo-random numbers. That's just happens to be where we're at right now. All right, so let's look at a couple of different ways. So that's a way of sort of getting some numerical Python arrays that we can mess around with. Suppose we wanted, I don't know, let's use the random. So that's numerical Python has a package that comes with it. So it's a library that has a package that comes with it. So the random package has these other things, and you can see you can get binomial, chi-squared, exponential, gamma. I mean, you can have a whole logistic. There's a whole bunch of things you can do inside here. We're going to use the shuffle command a lot. I'm not sure, we may or may not have used the shuffle, but we're going to use the shuffle later on when we get to do, when we're trying to shuffle like a list or whatever. So we're not going to do random, let's do rand_int. Let's do rand_int. Then what you do is you just give it a low number and a high number. And so I'm going to test this thing because I don't remember off the top of my head if this, and I want to know if the 5 is going to be included here. So that's really the question. So what I'm doing is I'm generating a random matrix because it's a 10 by 10 matrix. That's what you do. You give it the low number, the high number, and then the dimensions that you wanted. And what I'm testing is see if a 5 ever pops up. That's why I gave it such small. And it does. So if you look in here, you can see that there is no 5. And out of 100 numbers, if you have a random integers between 0 and 5, you would expect to get a couple of them. How about, what if I did 3? And there are no 3s either. So we see how this thing works. So that's, I just wanted to point that out because of this. It's not, if you don't remember how one of these functions work, just throw it in there and see what happens. If I set it equal to something, it wouldn't have been displayed to the screen and we had to do that funky little thing again. So but I'm just trying to show you different ways of coming up with different matrices that you want. Well, let's do a couple more. So B equals, we'll do random_int again. So np dot random dot rand_int, and then we'll go from 0 to 100. So I want numbers between 0 and 100. And in this case, I'm going to let it be a 20 by 10 matrix. We can see that up here, right? So 20 by 10 matrix, 20 rows, 10 columns. Pull it up. We can see that. We're going to mess around with that one here in a second when we're slicing. Computation. How about slicing too? So we're going to slice it. Concatenation. I'm going to put slicing in here too, just so I don't forget to do it. All right. So BC is equal to np dot random dot normal. So what a normal? You got it. And on the normal, you just tell it 0. Let's do something different. Maybe 100, 10, and then maybe 4. So what this does, it gives you normal random variates. So draws from a normal distribution that has a mean of 100, right? So location of the center, and then the scale is the standard deviation. Again, I wish they would have put that in here, but apparently a statistician was not programming this thing, so that's fine. But you just understand that's the standard deviation. And then 4, 3 is the size of the matrix. So we hit F9. We see that we get numbers that are sort of centered on 100, and they have a standard deviation of 10. So you can kind of see some of the stuff that comes out. Okay, so let's do one more. I don't think we need one more, but it's fine. You guys kind of see how this thing works. There's a whole bunch of different ways, and then the Jupyter Notebook could ask you to create a bunch of different, to get some practice doing this. So we'll be good with that. All right, so the next thing that we'll do is just a couple computations, right? So I'm going to say V plus W. If these were two lists, this would not work, or it wouldn't work how we would expect it to. So let's remember what V is. V F9, W F9. So V is this number, W is this number, and if we add them together, we get this one, so we get 15. So that makes sense. So 20 minus 5 is 15, 35 and 10 is 45, 15 and 12 is 62. Great. How about A plus V? What would happen then? Let's look at that one. So A, V, so A is this matrix, and then V is this vector. It's just like it's a row vector, although it doesn't technically have, it's a one-dimensional NumPy array. So think of it like that. But as you can see, it's displayed like a row vector. So let's find out what happens when we do A plus B, because something's going to happen here. Not always, but in this case it will. So what happened here? Minus 5 and 1, minus 5 and 4, minus 5 and 7. Is that what it came down here? I believe it did. So what it did was, it said, okay, A plus B, you want to do that, huh? Well, A is a 3 by 3 matrix, and you only gave me a 1 by 3. And so what I'm going to do is I'm going to replicate all of these rows and then turn that into it. So what it did is it created this capital V matrix that had each one of these as rows and then added them together. So in other words, -5 was applied to this whole entire column here, 10 was applied to this entire column, and 12 was applied to this column. That's called broadcasting. We'll get to that more. And there are some very cool things that you can do with broadcasting. Broadcasting is very, very fast. So that's what you want to do instead of doing a loop through here. All right, that's really all I want to talk about there. Let's do this. Let's find out what B is. Actually, let's do it this way. Let's find out what B is. What if I wanted this number right here? So slicing is a little different in a NumPy array. So B, so if we wanted this one, we go to the second row in the first column, maybe 2, 1. And you can see what happens when we do 2, 1. Let me move this up a little bit. We get 22, and 2, 1 is 22. What if we wanted the 75? Then we do 2, 2, and we get the 75. So you can see that you don't add the extra bracket here. So you don't put another, you don't put so this is not a list anymore. This is a numerical Python 2-dimensional array. So this works, and the other way would not. If we were trying to access a list, it's not a list of lists anymore. So what we would get if we go B1 and then 2. So 1, everything to the end. So what does that mean? Row. So starting on row 1 and going all the way to the end of column 2. So go to column 2 and go to 1 and go all the way to the end. So 18, 75, 20. You can see those are the numbers that come out here, which is kind of cool because now we can access. I don't know if you remember, but we had to do list comprehension in order to pull out a column of I'm doing air quotes here, a matrix before. So this is definitely the matrix kind of way of doing business. So we can access that just by doing that. So I can get that column, and I can even do pieces of that column. If I wanted the entire column, it would just be everything in that row, or everything in that, every row is what that means. So the little colon here means every row in that column, and that gives you even the 97. Let's see, what if I wanted, let's just pick out something random here. What if I wanted that little subset of numbers? So 22, 75, 82, we could do that as well. And what you would do, so that's kind of neat, I would go B, and in this case, I'm looking, and the first number is the rows, so I'm going to go to 2, And I'm not going to stop at 8. Remember, you got to go to the next one, 9. So it would be 2 to 9, comma. And then we want to go 1. So the columns are from 1 to 3, right? So it's not going to do 3, but it'll stop there. So what is that? 1, 3. All right, so hopefully it gave us what we're expecting. So 2275, we got that. We got 8220, 7492, and it stopped at 5955. Okay, so you see how slicing works, and it's a little bit easier than it was in Python lists. So that's a nicety. That's a nice thing for it to be very, very quick. All right, so suppose we wanted to reshape. Let me put that in there. So reshape. We're going to need to reshape at some point. So v dot, so let's remember what v was. So v was that row vector. So what if we wanted to turn into a column? Reshape length of v. If you don't know the length of v, so in other words, you're going to take some kind of row vector and turn it to a column vector. So this tells you the number of rows that I want, and this tells you the number of columns. So let's reshape it, and you can see that it now stands up, right? So it was laying down, now it's standing up. So it's a column vector now, which is nice to have. And if you hit F9 again, oh, it didn't stick, right? So it didn't stick when you do this dot reshape. So if you want it to stick, you got to go v equals F9, and then F9. Okay. And what I mean by stick is you're not really changing anything if you just do this method to it. You can do the calculation, like if you wanted to do something, do the calculation, but it's not going to make it stay. You got to actually set it equal to. Back up here. I want to redo v. I'm not sure if I'm going to use this later, and I'm going to call this v1 F9 and then v1 F9. Okay. So I'm gonna let v still be that row. It's not really a row vector. I mean, if I were to do 1, 3, if I reshape this as 1, 3, then it would actually be a row vector. But in this case, it's just a one-dimensional numpy array. All right, so let's do v F9 w F9. Yeah, we did all those already. Oh, what happens if I do vw v1 and w? So v1 plus w. Look at what that did, right? So again, broadcasting squared us away. So what it did was it replicated all these and turned it into a 3 by 3. It replicated all these and turned it into a 3 by 3. So it replicated all these columns, replicated all these rows, and then added those suckers together. And 20 plus -5 is 15. 20 and 10 would be 30, and then basically 35 applied to all these and 50 applied to all these to get the next one, right? So again, broadcasting, again, we're going to talk about that later, but I wanted to sort of introduce you to it. What happens if we wanted to do concatenation? So np dot concatenate is what you want to do, and then this is not going to work, but that's okay. Did I do w1? W1 is equal to reshape length of W, comma 1. Oh, W dot. All right, so we got another vector here, and I'm going to concatenate those two. This isn't going to work. I'm doing this on purpose. The way you do it is you put it into like a list. So these are the two things that I want to concatenate, and you would think that they would work because this is a 3 by 3, and where's W? And so what I'm trying to do is take this W1 and concatenate it to the end of A, and you would think that this would work, right? But it doesn't, and there's a reason why it doesn't. But let's figure that out. I think I got to move these out of the way. X. Okay, so it says something about the array dimensions, concatenation, blah, blah, blah. It's not really working for you. So the problem is what Python tries to do. So let's put those two bad boys back up here. So let me shrink them up a little bit. unless you tell it otherwise, what Python's trying to do is it's trying to do it concatenate the first axes. So axis 0 is all about rows. So think about it. That's the first number that you put in when we're sort of slicing through. You're talking about rows, and 1 is your column. So this is axis 0, and this is axis 1. So unless you tell it otherwise, it assumes that you want to concatenate this by what's called axis 0. So what Python's trying to do is take this array, this numpy array, and stick it underneath here. The problem is it doesn't have these two, it has nothing else to stick under it, right? So I could do the transpose of this. I could do, if this were a row vector, or I could do W1, which I think is already so that's already a row vector. But that's not what I want to do. I want to put this thing and stick it over here. So the only thing you have to remember is to tell Python to go axis equals 1. In other words, I want to do a column-wise concatenation. And then you see it works. If you want to do that row-wise one, you could do np.concatenate a comma w, and you can put axis equals 0. It's not going to be upset about it, but if you don't have to, because that's what it assumes from the beginning. Ooh, it didn't like w. So what did I do? Oh, yeah. So again, so let's do a reshape. Yeah, let me do a reshape because it didn't like that. I'm going to do w is equal to w is equal to w dot reshape. We'll do a 1 row by length of w. So the problem is it's a one-dimensional numpy array, and concatenate everything sort of has to match up. So the 3's have to match up. But I'm going to turn it into a 1 by 3 by doing this. And let's see what it looks like, w2. All right, so now it looks like Python wants it to look like, and we should be able to, yeah, that's not working. 1 by 3. Axis equals 0, maybe? Yeah, it didn't like that either. So let's see. A, W, dot shape. Oh, because I kept doing W instead of W1. I'm a knucklehead. All right. I was like, man, this sucker's got to work, right? No, W1 doesn't work either. Let's do W1. W2, my bad. Okay. Get these naming conventions correct. All right, so I didn't need any of this. This was me sort of, and it's not bad for you to see. I was going through and sort of trying to figure out why things wasn't working. And I saw that I had messed up and called it. So I'm sitting here saying, okay, I'm going to call this W2. And then down here I was doing W1 or W and W1. So you can see that what shape does as well. It tells you the thing. All right. So again, the point of this was not to sort of go back into the troubleshooting business, but it was basically to show you how to concatenate two things. I can do it column-wise. I can do it row-wise. And to also show you the axis command, right? So we're going to need that a whole lot in this class. So row-wise. And we're just going to go ahead and make this standard, right? So we're just going to actually tell, I'm not going to rely on Python to worry about it. If I want row-wise, I know axis 0 is my row, and I want to do a row-wise concatenation, so therefore I'm going to just throw axis equals 0 in there. All right, so what VStack and HStack do for you is a little different, but they're kind of cool as well. So np.vstack. So think about what it means by, so I'm vertically stacking something. And so what does that mean? Well, at this point, this is basically doing the axis piece for you. So this is just another way of doing concatenation, but now I know, but because of the letter that I used out here, which axes I'm doing. So again, it doesn't matter which way you do this. You just gotta pick one and get good at it. So in this case, we're gonna do the good thing about this one is it's not tied to dimensions. In other words, if there's 3 pieces here, a VStack will go in and it'll say, okay, well, since there's 3, it's a one-dimensional So if this were a one-dimensional array, it would not work up here in concatenation. You guys saw that earlier. Matter of fact, let's do that. Even when the dimensions lined up, it didn't work in concatenation. So let's change this to W. That's why it was giving us this thing, right? So the dimensions should line up here, right? Because there's 3 pieces, and you know, and it looks like if we were to print W out, it would look like a row vector. But the problem is things have to be perfect for, you know, like exactly, rows and dimensions all have to be exactly right in order for concatenate to work. VStack and HStack, just as long as I got 3 there and I'm trying to put it on the vertical side, then it's going to work, which is kind of cool. So vertical stack, you know, in your mind, sort of think of it as up and down, right? So I'm going vertically, and then if I'm doing np.hstack, we can do the same thing, but yeah, I'm thinking, oh, a W1. So that's right. So we turned this into a vector that stands up. So W kind of lays down, and W1 stands up, and it works out for us. Okay. All right. Last thing that we want to talk about in this video is just how to matrix multiply. You would think it would be as simple as this. So A, D. I didn't find D. D should have been something that I can multiply a 4 by 3. Oh, C. I think of 4. Yeah, we're going to do C. C should have been a 4 by 3. Okay, so C is a 4 by 3. So A, let's do that again, A and C. So I should be able to take this matrix and multiply it by this one. And this is a 3 by 3. This is a 4 by 3, so I should get a 4 by 3 out of it. But the problem is if you do A times C, which, okay, I was kind of hoping that would work, but it doesn't. It says we can't broadcast, blah, blah, blah. So nothing's good about that. But you can do np.matrix multiply. And you could do A comma C. So you pass in those 2 things, and it's in this order. Remember, matrix multiplication doesn't work backwards, so it has to be in the right order. Oh, it didn't like that. So did I put it wrong? 4 is different than 3. All right, let me make sure that I'm not a knucklehead here. Oh, yeah, it is. So A is a 3 by 3, and yeah, so this one has to be first. So yeah, I was just doing that last one to show you that it had to be in the same order, in the right order. Matrix multiply. This doesn't work, and why doesn't it work? Because this is a 3 by, so I can't take this row of 3 and multiply by this column of 4. So A times C doesn't work. So we need to do C times, so because these 3 times these 3 will work. These 3 times these 3, and so on and so forth. All right, well, that's all I got for this video. Hopefully you guys got something out of this one. We're going to start using this stuff in the next class, so just be prepared for that.